Okay, so the last thing we want to talk about here is finding the height of an object, which we call vertical motion problems. We're going to talk about these kind of throughout the rest of this quadratic unit. So we're talking about something that's going up into the air and coming back down. All of these problems, no matter which type we're looking at, is basically a quadratic function because, as you can see, the path that the object takes, no matter the type, is a parabola. So this one here where it kind of gets knocked off the edge, that's just half of a parabola. But nonetheless, all of them are parabolas, which means a quadratic function could model them. And notice for all of these, they're all reflected quadratics. So for all of these, the a value of the quadratic will be negative because they're all reflected, which means that the vertex is always going to be the highest point, or what we like to call the maximum. So that's going to kind of be a key word that we're looking for when we're doing these problems. But essentially what's going to happen is we could graph these. We could graph all of these in the first quadrant of a graph by measuring the height of the object, how high it is off the ground, versus time, how long since it's been thrown up in the air or knocked off the cliff. So let's look at a problem for that. So the height of a rocket launched upward from a 600-foot cliff is modeled by the function h equals negative 16t squared. So right there we can see that h, or that a rather, is negative 16t squared plus 48t plus 160. Notice how the height of the cliff is 160 feet and the C value is 160 feet. That's not a coincidence. That's always going to be true. The initial height is always going to be the C value. Because if we think about what a graph of this would look like, if we are measuring, I'm going to just say H for height and T for time, the rocket is starting at a 160-foot cliff. So right here is 160. It's going to go up into the air and then come down. So it's going to follow a parabola shape. So how high is the rocket to start? Well, they told us that the cliff is 160 feet. So the height to start is 160 feet. The starting height, again, is always C. When does the rocket reach its maximum height? So again, there's that keyword maximum. So we know that that is going to be the vertex. And so a vertex is going to be it has a coordinate, right? And in this case, the x coordinate is the time. So that's our x coordinate. And the y coordinate is the height. So if they want to know when is time, that means I want the x coordinate. And we know to find the x coordinate of a vertex, we do negative b. So in this case, b is 48. So negative b divided by 2a. A is negative 16. So that gives us negative 48 divided by negative 32, which is 1.5. So it's going to take 1.5 seconds to get to its maximum height. Then to find the maximum height, so what is that actual height? That means we want to find the y coordinate, which we find by plugging in the x coordinate for t. So negative 16 times 1.5 squared plus 48 times 1.5 plus 160. And if we plug that in our calculator, we get that the height is going to be 208, and this is measured in feet, so 208 feet. So this highest point is at 208 after 1.5 seconds. So that's how you answer these word problems having to do with vertical motion. The initial height is always c, and then the maximum height has to do with the h and k value of the vertex.